So in this week's video, I want to share with you a conversation that I had with Tyler from Alder Audio. He has some really cool insight into ribbon mics, ribbon design, and some really cool tricks that I haven't heard anywhere else, such as the impedance of air affecting the amount of low end that you get in a microphone. So enjoy this hang time with two audio nerds geeking out about ribbon mics.
Yeah, so I just thought that this would be fun. I forgot to grab them before we started up, but so I don't know how well you're going to be able to see these. Can you see that?
Oh, wow.
So I drew these in CAD and 3D printed them, very, very fine layers and whatnot. And so it's such an unintuitive concept that this can actually, roll, but these mesh, and this is like a thing in mechanical engineering, this set of gears. And so this is, I built my own machine that corrugates the ribbon, and I use this set of gears. Normally with ribbons, it's just a regular set of gears you're running through, just whatever, and with the right amount of teeth. But when I came up with that, the thing is, I was really hoping that I was going to get a benefit in the sound, to your question, because I was like, well, maybe the ribbon will not have a resonant frequency, because it's not just a stretched corrugated thing. It's got this, thing that maybe damps it a little bit. And so I was like, oh, it's going to, I'm really optimistic. So I always thought it's going to, make this amazing sound. And I put it in there and it just did nothing. Like the sound wise, it really was exactly the same. And then I got into where I built my own, got a setup for QC. Everything gets frequency sweep before it goes out the door. And so I started to be able to test frequency response with the herringbone versus not. Zero detectable difference, which blows my mind, actually, because physically you can see that it deflects less when you blow on it.
Oh, yeah.
But sonically, I can absolutely detect no difference, which to me was a disappointment, because, I thought I was going to get some benefit out of it. But the benefit is the physical. It's just that it's, more resilient and all that. So
yeah, I remember seeing your video about that, and it's amazing how much the ribbon actually flexes in the traditional corrugation versus the herringbone pattern, where it's rigid. And I really like your story about manufacturing. If you want to make something stronger without adding weight, you need to add an angle to it, and it makes it stronger. And that's what you did. You added an angle, and now we have a stronger ribbon.
Yeah, and I think people can kind of intuitively get that. Like if you imagine it like a folded piece of paper, where the paper, if you just accordion fold a paper, versus if you could imagine, you couldn't get it on something as wide as a piece of paper, but if you could imagine a paper folded like that, you just get how much stiffer it is from those two angles of bends being in the piece. And so I think people kind of, just an intuition to that you can kind of get, oh yeah, this is more resilient.
Yeah. It took me probably years to actually, probably just because of the volume of a guitar amp, but it took me years to actually get down close to the amp while it's blaring loud and actually look and see what's happening to that ribbon when it's in front of the amp. And it kind of made me nervous, to see how much it was actually jumping, because it was like, ooh, I don't know if I want to see that, because it's moving.
Yeah.
I want to say on a typical ribbon, it's a good quarter to a half inch maybe. I don't know. It's a lot.
Sure.
And,
yep.
It was I don't know. I haven't broken the thing, so I guess I'll just keep using my gear like I have. But I had no idea it moved that much. So
yeah.
Well,
that's why Royer puts theirs up front, because they have a patent on that. So the reason that theirs sounds different back and front is because they offset the ribbon. So the ribbon on the front side is actually right at the face of the magnets, right up close to the front, or at least closer, so that when the ribbon blows back, it stays inside of the magnetic field in between the magnets. And so, that's how they came up. They originally came up with that to handle higher SPL, but then they found out that there was a sonic difference, that when they turned it around, it sounded a little different as well. But yeah, it's kind of terrifying to work with ribbons. And when I first started, I was scared of them because I'm like, I was breaking them when I was corrugating them, and it's almost amazing that it works at all, that ribbon mics can even be a thing, because the foil is so thin and so fragile. And I was working with them, and I'm like, I'm terrified to make a product out of this and send it out the door, but the amazing thing is that once you get it suspended in its own weight, this is my opinion on it, is that even a regular corrugated ribbon is not going to stretch out. If you've pre-stretched it a little bit, you need to do that, but it's not going to stretch out under its own weight, because it's also very light, right? So like if it just hits the ground or drops, like under its own springiness, it's not going to bend. The problem is when you get high air velocity that blows at it, that it can go. So that's why, even though they're super fragile, which is scary for a ribbon maker, it actually works. It's kind of amazing that it does. But I it freaked me out, and I wanted to do anything I could, even for my own self, to be like less scared of putting it in people's hands, because I really want it to work for them. And so when the herringbone thing started working out, and I started working with ribbons a lot, I was like, this makes me feel so much more confident and so much better that this is gonna hold up out in the field.
Yeah, and you were saying that, in like a microphone drop, if something, happened when you're handling it, if it's in plastic, then it doesn't get that burst of wind, and it's a lot more likely to be just fine because you're protecting it from the wind, and so it's more of a wind issue than a shock issue.
That's been my just experience with working with them a lot, and I do think that that's true. It's not like I have it, proven with some kind of test. The way I figured that out, though, is just that I've got foam inside of my case, the one you've got behind you there, and I did see, like, there was one that must have got handled really rough because, there it is, and somebody got back to me and said, hey, like, the mic sounds good, but it's really kind of low output. Yeah, there it is. And so I had them send it back to me, and I looked, and the ribbon was bent. And so I was like, well, I know that my herringbone ribbon at a baseline is good, so why did this bend? So I just did a ton of like in the box drop testing and back and forth, and I wasn't shipping them in a plastic sleeve inside the box, and when I put a plastic sleeve on there, the difference was crazy. Like it would go from, I could drop it like a couple feet, maybe 3 feet, was maybe it could stand that, to like, if I put it in plastic, I can drop that box from 6 feet, like from my full, at my head to the ground, flat drop, and then I take it apart and the ribbon is still intact. And so my understanding of that is that the foam from the box was getting, squashed a little bit and puffing out, and then that was a little puff of air that was puffing the ribbon, because I don't think it bends under its own weight. It's the air. And so just having that plastic sleeve, it was like night and day difference.
Wow.
For the durability and shipping. And so, that was a big thing for me, made my shipping a lot more, robust. I'm much more confident to like ship them internationally now. That's going to be much more confident to, you're not going to have problems, even if it gets dropped off the truck, But I think for other people too, that's good to know for the ribbon mics, that if you're traveling with them or whatnot, always great to just like put them in a Ziploc, put them in anything that if they get jostled, they're not going to get that, wind or little, it's so hard to think on those terms, those like little tiny fragile terms, but just a very small poof of air that's just fast is enough to do it. So
yeah. So, like, one thing that I would love to just stress and kind of advocate for people using ribbons, and maybe people that are nervous about it, is that, it's really not that bad. I mean, I keep them covered. It's just like a condenser mic. I mean, I'd keep a condenser mic covered. I would, make sure that I don't use phantom power. With a condenser mic, you're mindful of that too. Okay, is it off? Cool. I'll plug the mic in, and then, okay, I'll turn it on, and little things like that, But the cool thing about it is that, ribbon mics are fairly primitive kind of little transducers and creatures of audio, right? And so you're getting the benefit of a really good sound, and you're not having to, kind of as a consumer, you're not having to pay for really expensive parts necessarily like capsules and things that are like, take a long time to develop and make. And so it's almost like you're getting this benefit of a detailed mic. But, I mean, ribbon mics are, you have, within dynamic mics, you have moving coil and ribbon. And so, you're getting a robust, warm, but detailed mic, and it's really reasonably priced, too. And that's like such a good benefit of ribbons.
Well, that was my goal too, is to be able to do like a high-end ribbon mic, and like make it in the U.S., make it kind of that, really nice materials and whatnot, but still offer it at a reasonable budget. And that is challenging, just because like designing ribbon mics is a whole different animal than designing like a condenser and whatnot, because it's all physical. Like it's all, for me, the sound of the mic, it's all geometry. It's physics and how it's laid out and materials and all kinds of different stuff like that. And like, this is a bit of an aside, but I love acoustic guitars. I love like high-end acoustic guitars, and there's something about playing a fantastic acoustic guitar in the room in front of you that you can just never replace that feeling. To me, that acoustic sound in the room is just like, when you get a really good one, it's fantastic, and it's all because of how it's braced and the type of spruce it's made out of and stuff like that. Like, and I think that's kind of ribbon design as well. So with ribbon mics, like, I think I haven't done a ton with like the lower end ones, but they're starting to get to the point where, like, at least they make them out of a thinner foil instead of something thicker that's going to sound really flabby. And you can kind of, make the copycat cheaper ribbon mic that does okay, but to be able to make a mic that really kind of does a thing, has its own character and has that kind of extra zip to it, it's intricate design, and I had to try to do that while saying I'm going to make these at a lower volume and still do a good price on them. So I had to start from the ground up with the design and say, how can I accomplish that? Which has been really fun and really rewarding, because I'm glad that, like the Sound on Sound review just came out, and they put it right next to the 121 and the Extinct Audio BM9, and they're like, this is a third the price, and it holds its own in this company. And so I'm really proud of that.
So the H44 and then the H44S, and the S is just the symmetrical, where the voicings are the same, where the H44, the front voicing is slightly different from the back. Mm-hmm. So why don't you talk a little bit about that? What does it mean by the voicings are different in the front and the back? Is that kind of like what Royer's done, or is it just a different way that you get that effect?
It is a different means. I mean, just on the face of it, it sounds different from the front versus the back, right? And most times if people even use a figure eight, I mean, maybe for some more beginner folks, they don't realize that you can use a figure eight, just use one side of it. That's almost always what you're using. I used to think somehow if you had a figure eight mic, you had to be in some situation where you were, needing both the lobes on both sides. But no, it's fine to just use the one side. And so yeah, I have that in common with Royer as far as it sounds different from the front and the back, but the way that's achieved in the design is completely different. And so, like I said, it's all geometry. It's manipulating these forces of physics. But anyway, with the H44, the front different from the back, it's manipulating geometry, and the front of the H44, so the one I'm speaking into right now, which has the logo on the front. Suppose we can show one of the mics here. So this side on the H44 that's kind of the funky side. It's like the non-standard ribbon side. In my experience, I really developed it for vocals. And so for a ribbon mic, like normally ribbons to me, it's like they're okay on vocals, but they can be a little boring, a little flat. And there's stuff that I did with the design of the front that I just really like on vocals. I also like it for a kind of punchier sound on acoustic instruments, especially like mic'd close. But then the back of the mic is much more open. So when you switch from the front of the back to the back and you have headphones, I feel like it's so hard to describe sound. But on the front, it's like you walked into a room and you're speaking. And then when you turn it around to the back, it's like you walked outside. It just kind of opens up and is more natural and less punchy. And so anyway, yeah, that's the two sides on the H44. But then there's people that say, I really don't like it for the mic to be not symmetric, because they want to do like a Blum line, especially like, if you got a bluegrass band and you want to like surround a Blum line array with a bunch of people and have them all recorded there, you want all those voicings to be the same. Or mid-side, you can do mid-side with a asymmetric mic. The phase will work, but the sound will be different on the two sides. So it's kind of an interesting topic. But for those situations, I was able, because of the way that the design is, it's not an offset ribbon like Royer does. I was able to do a design where it's mostly, it is symmetric, and it sounds almost exactly the same as the back side. So the more natural, normal, what you expect from a ribbon kind of sound. And I actually recently changed this one. I updated the logo. So the
cool.
S has a black logo on it. That just changed. So people can differentiate them now. So yeah, anyway, if you want versatility, you go with the H44. That's what most people go with. But if you want a symmetrical response, and that's more valuable to you than the versatility, people go with the H44S.
I mean, yes, it is different, but it's not where it would keep you from really using it in like a Bloomline situation. Like we've done it here for room mics, and it sounds great. And I guess if you really need like a mid-side, perhaps, where you're over a drum set and might be more noticeable, but it is very much. They're like sibling sounds, like they're very close.
Yes.
They're just kind of little tweaks on that same sound,
There are times when you can hardly tell the difference between the front and the back on some sources, and then in other situations and sources, it's like blatantly obvious.
Okay.
It's a huge difference. When I got the front sound for vocals that I really liked, and I was like, this is great, but it's a ribbon mic. It's really not that conducive to plosives. That was a difficulty. And I wanted to make it better, so I started testing different materials. So the first thing I did was put a foam windscreen over the top of it. It was actually, one of the development models that was thinner, and I put a shotgun mic foam windscreen over the whole thing. And the thing is, it changed the sound drastically. And so I was like, wow, what's happening here? And what it did is it lost low end, which is not what you expect. With a condenser mic or something, you're thinking, I'm going to lose high end and I need to open up the basket so that, I get more clarity to it. It's going to be muffled. But no, I lost low end, and then I went and learned about it. So there are these amazing articles from the BBC from like the 50s on the development of the mic that became the Coles. And so that was originally, a BBC mic, and they have all this really cool documentation that used to be internal that's now been made all public. So you can go and like read the technical bulletins of the engineers that they were reporting inside of the BBC when they were developing that mic, and they describe the exact phenomenon that I discovered with the shotgun windscreen over the top of the mic, and that's that the ribbon inside is different than a regular dynamic mic or a condenser, in the bit that it's so light and sensitive that the low end that translates, the limiting factor to the low end is actually how difficult it is to move the air inside, not necessarily the ribbon. And so if you make the air harder to move back inside, you reduce low end. And that's what happens when you put a foam windscreen over the top, is that you've raised the acoustic impedance of the air, which is a concept you don't hear very often. You've made the air harder to move, and that actually lowers the low end pickup. And that's different than any other mic. It's only, to my knowledge, ribbon mics that do that. And in that technical bulletin, they go into it. Like they put this kind of metal gauze mesh, and they needed to attenuate their low end. And so they designed the head basket to be X amount permeable to air to like dial in the low end that they wanted. So it's like an intentional design choice. Yeah. And so when I did it, I put that, shotgun windscreen over the top of it. And I was like, well, I don't like this. I want my low end back. I want that, big ribbon sound. And so I took it off. But what I found out after I went through all that technical stuff is that I can still guard from plosives without raising the impedance much, at least of the air inside, if I only screen it on one side. And so the front side has a little bit of extra protection, the back side does not. And if I were to take that extra protection all the way around the back, I lose a lot of low end. But with it just on one side, since it is an asymmetric mic already, it is before the screen goes on there, I can do a little extra protection for plosives on the front without kind of throwing off the whole mic. And so that's only on the H44. It's already symmetrical, so I thought I can put a little extra protection from plosives just on one side. With the H44S, the whole head basket has less protection, more open, same on both sides.
Yeah. Yeah, so thinking back to kind of my tests, as I remember on the front, you could tell the high end was more shaped, I guess. And it was kind of like, it kind of rolled off, and then it kind of had like this little uptick towards the top where it was like this top end air to it. And then the back, it was just more, I guess, even on the top end and just kind of more just wide open and naked sounding, which I guess that makes sense if there's less protection on the mic. But I mean, either one sounded really good. So and there's not really a bad option,
Yeah, I'm glad to hear that. Yeah, it's definitely something that you get to know, because it's not like a mic with a switch on it where you're like, okay, this switch is programmed to like roll off something or to make it. I had a mic that had like a focus button on it, like it's a circuit that it's engaged, and they intentionally designed that circuit, so it's very easy to say, well, this makes it brighter or whatever, and that's not what this mic is. It's like a two different, slightly differently designed mics from the front and the back, and they respond differently to different physical situations. And so you're doing the same thing I've been doing for months, trying to tell people about the sound. You're like, well, it's not just this. And I think the best thing is to tell people what I like to use it on. And I think that that's been other people's experience too, where they try it on a lot of things. What's really, really great is you can just turn it around really quick, so you don't have to swap anything out. Like you can try the two sides really fast. And my favorite experience with that was one guy that had one locally here, and I've been, doing some work with him, and he was like, maybe I ought to swap out for a symmetrical one. Like, I only ever use the back, and he's using it mostly on drums and loves it on drums. And I called him up a few months later and wanted some feedback, and he's like, you know what? Been really liking the front on vocals. And and so like, if people, you get to know it, it's a craft thing. It's not just like, here's the chart for where the frequencies go. It's like getting to know an instrument.
Oh, I'll never know what makes us men with all the love that his heart can stand, to dream of ways to throw it all away. Oh, gravity is working against me. Gravity, oh gravity, wants to bring me down. Oh, I'll never know what makes this man with all the love that his heart can stand, to dream of ways to throw it all away.
All that is a design choice, to be like, how focused and guitar cab centric do I want to design this mic versus I want it to be open for other sources. And so but I think that at the end of the day, you want different mic sounds for different situations. And so like, sometimes you might want that focus sound, sometimes you don't. Another thing, and I think we've emailed about this a little bit, is that it does have a lot of low end. And so, like, I don't know if you would think this or not, but I would guess on that Royer that it might get a little heavy on the low end compared to the Royer on the guitar cab. And that's actually where we were talking about. I had the idea. I was like, you know what? I haven't done this myself. I still haven't done it, actually. But I said maybe it's worth putting like an SM7 windscreen or something over the top to use that impedance trick to kind of physically, roll off the low end, which I think is kind of more interesting than doing it with an EQ.
Yeah.
And so that's, I didn't get around to actually doing that myself, but for either this mic or other ribbon mics, that'd be kind of an interesting technique for people to, if you're micing something up close and you got a little too much low end, and if you have an undamped ribbon mic, so something that isn't already built in with a lot of damping in there, you can try to fit a big windsock over it and see if that gets you the right attenuated low end.
I don't really find the low end a problem. I mean, most of the time, everybody's high passing guitars anyhow, so it's
that's true.
It's like, why would you not high pass a ribbon mic on a guitar cab? There's always some sort of bigness, kind of rumble going on. I definitely heard it more with the H44, and it made me think, first of all, it's like, whoa, like it's like a hot rodded transformer in there or something, because there's so much like energy that it's able to give off and transfer. As far as I understand, like that's why a lot of ribbons want a high impedance mic preamp to try to capture as much of a broad range as possible where you get the low end. And I noticed that, like on my R88 by AEA, like I'd never heard as much low end until I got their mic preamp with it, for example.
Sure.
But with your mic, I'm hearing like frequencies all the way down to like 40 and 35. It's just like, this thing is nuts, and there's this demo on your website of this drummer guy, in his studio, and he's a great drummer, and like the floor tom sound and the kick sounds, like it's incredible, like it's nuts.
Yeah, thanks. I didn't film that one. The guys that filmed it, they were really excited about that because they wanted to try a whole bunch of different, mic techniques and stuff, and so they'll certainly be glad to hear that. And yeah, it is a great drum mic, just kind of all around. you mentioned the transformer. I am really proud of the transformer because I do wind them all in house. So I designed it. I went through a lot of testing and different stuff. I wound all the first ones by hand. So like when I was first getting into ribbon mics, I'm talking like I cut up a credit card, like this, like the side of it, and wound, like hundreds of feet of wire, and then passed it through the toroid. So that's a brief thing on transformers, is that a toroid is like a donut shape, and that's a much more efficient, good way to go with the transformer, but it's very hard to make because you have to wind hundreds of wraps through a donut. You can't just spin it on a mandrel or something.
Yeah.
Like you have to do this thing, and
Oh
so
my
you have to get a very special machine to wind those, and I was winding them by hand when I was developing them, hundreds of winds with this bobbin through the donut. And but that was a big thing for me, is that I wanted to make a custom, really nice transformer that was matched to the sound that I wanted. And I actually broke a few rules when it comes to impedance and whatnot, because the impedance thing with ribbon mics, it definitely is a thing. And I'm gonna create a video on this. I might launch it quite soon, so it might be coming out over on the Alder audio channel close to this video. I think I'm gonna do a 3-part series on impedance, because I cannot find great information online for impedance, and then there's also a lot of confusing information out there. But I won't go too deep into it. But all I'll say is that in my opinion, a great way to think about impedance is the ratio of the voltage to the current. That's not the way everybody describes it, but if you just think of your classic Ohm's law, your V equals IR, and if that R in AC instead of resistance, it's Z, it's impedance. So your Z is your voltage over your current if you rearrange that, and that's a great way to think about it. And the reason everything gets complicated with AC is that everything changes with frequency. So impedance wouldn't be interesting if it was the same for all frequencies. So when you look at the impedance rating on the mic, the standard is to measure it at 1,000 hertz. And so you just measure it, you say that's where it is. But everybody knows that once you get to the low end, it really starts to go up. And that's what you're worried about with those preamps, because what happens is that the preamp is only reading the voltage. So you got like a transistor in there, whatever, that's your input stage. And it doesn't care about the amperage, it's just reading the voltage. And it's going to have an input resistor, and that's the input impedance. And so once it goes in, it's going to take that natural ratio of the output impedance, the ratio of the output voltage to the output current, and it's going to squash it. It's like putting your finger over a garden hose, kind of like it squashes it down.
Mm-hmm.
And if if the output impedance is too high, the voltage starts to fall off, and you start to, because if you have like the 10 times rule or whatever, your input is 10 times your output, then you've got a lot of force behind your garden hose on your thumb, so but if the ratio starts to come up, that's my shorthand way of describing it. But the result is that you start to lose low end, because the impedance changes at the low end, so you get to the point where you start reflecting back voltage instead of current. And that is not necessarily a bad thing. I've got actually one of these guys here. I've been talking to Cloud. Have you seen this guy?
Yeah.
Cloud lifter with the variable Z on it. You can intentionally mismatch the impedance and kind of get this interesting low end kind of roll off. And so it's not always a bad thing. And the H44 already has so much low end in it that if it starts to lose some in the interface, it's not the worst thing in the world.
Right.
And so the impedance of the mic is actually high. It's higher than other ribbon mics, but it has so much low end in it already. The thing is, if you plug it into one of your you have the nice ribbon preamps with they must have a real high input impedance, you're probably going to get massive low end out of it, because it has a good low end in a standard preamp. So I don't know, that was a little technical impedance deep dive, but hopefully that made sense.
No, it makes a lot of sense, which is actually really cool to hear, because the mic will do very well at kind of a standard mic pre. You don't need something Yeah, like a normal mic pre is what, like 1200 ohms, and like the AEA is 63,000 ohms. I know the Focusrite ISA preamps, they go between 600, 1200, I think 32 and 8,000 ohms on their 4 settings. And then like the warm audios were like 600 and 150, I think. So yeah, like we've been playing around with impedance for a while, but it kind of your normal interface that, somebody that's just getting into recording and they want a nice mic, right? Like this is a great way to go, and it's going to actually work with the preamps that you have,
It's a factor that matters. It's nice to know about, but you don't need to be worried about it. Like this mic was designed and made so that it sounds good with a regular interface, and with that in mind. Now, if you know about impedance and want to use it to your advantage, you can get more low end out of the mic, or you can dial back the low end. Like you can use all those tools. So they're important, but you don't need to worry about them. It's gonna work. I was looking at your channel, and you had a video not that long ago about buzz, and I wanted to ask you, have you experienced any buzz with these microphones? Any problems at all with them that way?
I haven't found that, so.
Okay. Well, that's good. Well, I'll just say it's been a big topic for me, because it's real weird. Like I've got ribbon mics that can be dead quiet in my space, and then sometimes I send them out to people, and especially at the early days, I would get feedback of like, this buzzes in my space or something like that. And that's difficult as a maker, because I can't reproduce it. I don't know what about their environment is causing a buzz in the mic. It actually led to this ridiculous experience where I loaded up my interface and my computer and all my stuff and put on headphones in my car and like drove all around Ann Arbor trying to find buzzy spots because I'm like, something about the power grid in certain places causes more buzz than in other places, and I couldn't figure it out. But to this day, there are some places that I've seen more buzz. And where it really broke open for me is this one guy was out in West Coast somewhere, and he told me that he had all this problem with ribbon mic buzz in his space with other brands. And he's like, I've tried this, and I've tried this, and I've tried this. And oddly enough, it was like the original R44 or the RCA 44 that worked for him. And he's like, that one doesn't buzz, but I've got all these modern brands and they all buzz for me. And so I said, well, try it. And if it doesn't work, I'll send it back. And, I sent him mine and it buzzed. And so he sent it back, and I thought I'd try. I was like, let me try one thing. And I shielded the transformer in mu metal. And so mu metal is just like a really good magnetic shielding material. And this is something that if you're hunting down buzz, this is like something to know about just audio equipment in general, is that usually when something buzzes, everybody assumes it's like radio frequency interference or something that they can like, let's shield it. Let's put a Faraday cage around it to ground it out. And you cannot ground out magnetic interference. So it's the same thing that causes the single coil buzz or single coil hum. It's that 60 cycle, and it's because of AC transformers. Like there's transformers all around us converting AC electricity, and they cause a flipping magnetic field. And it's not like an electromagnetic, thing like a radio frequency or anything like that. It's just a purely flipping magnetic field, and then that flipping magnetic field can induce a voltage in wraps of wire, which, a transformer for a ribbon mic, because they're so high a ratio, they have a really high, wrap count and inductance and all that. And in my experience, so the thing is, we use the toroidal ones, the donuts, and those by their nature reject hum because they're symmetrical, and, if you see it from this side, then it's gonna, do the opposite from the other side. But I'll tell you, something about environments can still cause those to hum. And so I think that those other the other mics that guy was trying, where he was seeing buzz, had, I'm guessing, unshielded toroidal transformers, which normally works. But I put that inside of a shielding can, and a magnetic shielding can, it just like, it reroutes the magnetism around the item instead of grounding it out. It's a whole different thing. And it solved the issue.
Wow.
And so that's something that at the beginning I was like, maybe this is a one-off, kind of thing. But I've decided to update to that. So now everything that goes out the door gets a standard mu metal shield can. And I just had another case of somebody who said that in their place it was buzzing, and then I replaced his mics with shielded mics, and he said the buzz is gone.
Wow.
Which to me blows my mind, because I can't reproduce it. I don't know where this is coming from. I'm like, are the transformers near your house like different from the transformers? Like, are they toroidal power transformers? And that's what I don't know. But hunting down buzz can be this crazy thing, and it's been a good topic to learn about. So,
yeah, that's hilarious that you drove around. Like, I just imagine like somebody calling the cops, like, there's a strange man, like,
with headphones and a microphone.
I think he's an audio engineer, but he's just walking around my neighborhood.
I grew up, my dad was an entrepreneur, and totally different business. Actually, several businesses. I'll do a super brief version. Is he was a cowboy, like rodeos, roping. He had a Western shop where he sold boots and hats and did shoe repair. And so we're repairing cowboy boots. And somebody brought him a leather motorcycle saddlebag to repair. And he found out these are really valuable and they're kind of this niche item. He's like, I think I can improve this. So he started a leather motorcycle saddlebag company that I worked in high school. So I grew up kind of watching my dad do these various, brands and stuff, and he patented a bracketing system for this thing, and he got it off the ground, and now, like, my brother runs it. They've got, like, 12 employees. It's been a really cool thing. And I grew up, like, bolting those things together, like vacuum forming plastic, and so I just, from the start, had this mentality of, if I see something that I think is really cool, I'm always like, maybe I can make that. Like, there's not a barrier there, because I've just seen that can happen, and I have that visceral experience. And so, with ribbon mics, that's part of what got me into it in the start. I do all kinds of audio projects, but it was like, I can make this. So I've got that background. My first ribbon mic, my brother laser cut it for me at the leather saddlebag shop. We drew it together, and he laser cut some parts out of metal. And so laser cutting is really powerful, CNC laser cutting. But I wanted to CNC laser cut a tube, which is a lot harder. So it took some tracking down, but that is how these are cut. And
Wow.
So stainless steel tube, really long, and then, I've got the model that I drew in CAD, so I designed all this in CAD, and then it goes through a process where it cuts it out, but it's real rough. So, wish I had one here, but I don't have one in front of me. And so it just comes out, looks like a raw pipe that has all the holes cut into it. And then I have to individually drill out the holes so that they're exactly the right size, and then tap them. So I've got a tap jig, so it's nine tapped holes that have to be tapped with a drill. And then the whole thing gets polished by hand. So it gets chucked up and kind of sanded and buffed, and it's got brushed stainless finish. And then it's a very different design because it uses set screws. So most other mics are built where they have a screw that goes through that bolts in, and this one the wall is tapped, and then it's all set screws that holds it together. And so that's why it has that real kind of clean look to it, because it doesn't have these big bolts sticking out the side. But yeah, it's just it's manufacturing processes, laser cutting and drilling and polishing and sanding, all that kind of stuff.
I mean, these things look great. I mean, they really do.
I love working with stainless because anything that requires a finish on it, like that's painted or whatnot, you can always chip off or have defects or different things. Like I do a little woodworking, and finishing is the worst part. Just trying to get that all even coated and everything. And that stuff is conducive to large scale manufacturing. If you want to make something large scale, make a machine that does it perfect every time and make your components as dirt cheap as possible, and then just paint them with something that's going to protect them, and then it looks real shiny and nice and, real professional looking, and it's cheap. But I just really like working with the stainless because it feels very real. It feels tangible. There's a weight to it and whatnot. And when I put that brushed finish on there, I mean, there's no coating. You know, it's a quality material that's going to stand up to time. It's not going to rust, and there's nothing to chip off. There's nothing to get muddled there. It's just brushed stainless steel.
So what kind of feedback have you been getting from people? Like, where do they like to use the mics?
So the biggest feedback I got from the start is people loved it on overheads, either overheads for drums or room mic for drums. One of the first comments that I got was, I can't believe you designed this to be a general purpose mic, because it really sounds like you designed it to be an overhead mic. And so that was pretty fun. But the way the mic works, it is like the design of the transducer itself is very narrow. And that's a thing with ribbons, is that the distance from the front to the back, you get less proximity effect that way, but you also get a little more high end, and it's got this naturalness to it. So the mic does have that advantage to it, kind of an openness. And that means that it's not like a one-trick pony mic. So it sounds very open on drums, but I hear people using it for different sources all the time. Somebody else came back to me and they said, "You have got to talk about this on trombone." I was like, okay, specifically trombone, because they were recording like a professor of trombone, and this guy came back and he's like, "This is the first time in 17 years that the mic sounds in my head the way that I hear my trombone in person, or that I want it to sound like." And so that was super random. I've never recorded it on trombone. I've never tried it on trombone, but you get that delightful thing where somebody just goes and uses it on something. But yeah, I've definitely had people really like it on brass and woodwinds. I've never even heard it used on violin. Somebody asked me for a violin demo the other day, but I think it's very well suited to strings. Somebody really liked it on banjo. And then the one that comes out of nowhere is the vocal for the front. So there's definitely been some people who really like it on vocal, which I was happy with, because that was a totally my ears thing. Like, I developed that voicing, and I said, I think this sounds good on vocals. Who knows if other people think it sounds good on vocals, right? And so then I've been trying it with different people, and it's got a great alternative to a condenser sound. So like, if you were thinking about reaching for an SM7B or like something that's a little different, not so crispy, and if it's a little harsh on the vocal, it's a great option. I like it on my voice. I've actually, I'm just a home studio guy, but I've switched all my own vocal recordings to this mic. So I'm a tenor. Tenor voices are good on it. And then even creative things. So like I said, the overheads on the kit, but people really like it in a room, or like for a kick out mic. Or I know that I mentioned to you this technique that is apparently common here in Michigan, because like there's a professor at the university who's a fan of it, where you put a figure 8 mic on the side of the kick drum. So it's like parallel to the kick drum. It's kind of almost like facing the bottom of the floor tom. Mm-hmm. And because it's figure 8, and the back side of the figure 8 is opposite phase from the front side. And so same with the kick drum. The kick drum, different phase, just like a, top and bottom of a snare drum. So if you put it on the side of the shell, facing front and back with the kick drum, it gets some positive pressure from one side and negative pressure from the other side, and it just kind of works.
Yeah.
And it's a really cool, interesting technique that people love for a figure 8 ribbon on kick, and that's also been a fun one.
Yeah, so your drum demo video, it's a video with just the drummer, and that guy got some amazing drum sounds. Like, I didn't know that it could sound that good, with ribbons, because...
Yeah, 3. That's it. 3 ribbon mics.
Yeah. Just really, like, bombastic, like, over the top, like, tom sounds that you dream of getting, I'm doing a terrible job even describing it, but it's like that really crazy, like, floor tom sound and kick that just is just really in your face. A really, really cool drum demo. I'm
definitely I'm really happy with that one. And that was all of the passion of the guys that did it. So that was the first one that they did, and they had just been introduced to my mics. And I asked the guys that made that video, they're local here, a couple graduates from the University of Michigan. And
so is it the same guy that did the it was like the drum only demo, and then you have like a whole band video that's like an old.
Okay. Yeah, so no, that's not the same. The whole band video was an artist named Lamont Landers, and that was done at a studio called Clearwave Recording Studio in Alabama. The guy's name's Jeremy Stevens, and he did a fantastic job. And Lamont
awesome.
Landers is a really cool singer as well. Like, I love that whole thing. So yeah, they did like a produced version. And so that was just fun in and of itself. And, you know, if people watching haven't seen it, what he decided to do in that demo is do a full mix, and he used it on 5 sources, the mic. And so he goes around the studio and he'll have the full mix going, and then he'll solo it to just one source with the H44 on it, and then he'll back out to the full mix. And so he'll do that on vocals for a while, then he does it on guitar for a while, and then drums for a while, and whirly, you know, he just kind of goes around. And that was really fun and a great way to show off the versatility of the mic. So yeah, that one I was super happy with. He's a great guy over there at Clearwave, Jeremy Stevens. But all the other demos on the website, just the real simple kind of backyard looking demos, were recorded by a couple of young guys here in Ann Arbor that are recent grads from the PAT school, they call it, at Michigan, the Performance Arts Technology. And they were really excited about the drum demo, because I was talking to them and I said, all right, you know, if you guys, I'm not a drummer, if you wanted to see a drum demo, what would you want? And they had a lot of opinions about that. And they, and so, because they said, you know, you listen to drum demos, they give you one mic position.
Yeah.
And you're like, well, you know, and one style. And so they're like, I want to know how it works in different positions, different styles. So they got a local drummer, and then they just kind of spent a lot of time with a bunch of different mic setups. And so it's a great drum demo in and of itself. Every sound was just three of these mics, no processing. You know, they're going direct into a Mo2 M8. You know, there's nothing fancy going on but the mics. But then they did a lot with techniques with 3 mics. So it's a good demo, but it's also kind of a good technique video. If you want to like steal some drum techniques, like that side of the kick technique is in that video, and you can really hear it's got a different vibe going on.
Yeah. So, you know, for those watching and are fans of Creative Sound Lab, like both videos are like goldmine of information, because first of all, like the overview, like the song video of this guy, you know, like they're doing this whole song. It's one of those videos I wish I made myself. You know, it made me jealous of like, man, this is such a cool video to go through in context, you know, and like pull it off to where it's like, it all sounds really good. It's catchy. It's got a great flow and energy to it. But the drum video is really cool because the sounds are just out of this world. Like, it's the kind of thing that if you put like an 1176 compressor on some of these sounds, it'd be like, oh my gosh, like that's amazing. You know, like the kick, like the front of the kick mic, for example, sounded really cool. The floor tom, I remember, just was like, oh my gosh, you know, like that's amazing. You know, the overheads were like, okay, cool, that sounds like overheads, you know. But there's some techniques that you mentioned that it's like, I haven't seen that technique before, you know, and that's something I should try, because it's out of this world how it picks up the proximity effect, and it's not like a typical kind of like worst position or crotch mic, or, you know, kind of like a mic underneath a ride cymbal would be. What you're describing is a bit lower towards the floor tom, and it picks up the kick a little bit differently. A lot of times the kick on those positions will sound really mid-rangey, really kind of almost telephone-like, but this sounds really gnarly in a cool way.
Yeah, I love stuff like that can, you know, even if it's doable in a different position, something like that, it just gives you that different flavor that's kind of unexpected, and it's always hard to put this stuff into words, but that's always an encouraging thing to do, is just if you find something that's going to be just a little bit different than other people do it and still sounds good, you know, it's going to give you a little interesting vibes. Like, that's not the standard, you know, it's going to give you a little fascination factor. So you can find all the info at just alderaudio.com. You can also find me over on Instagram. We post our stuff there, and then there's an Alder Audio YouTube channel. It's a unique name, so it's easy to find. And as far as what's coming down the pipe new, really it's starting to get our name out there because, we've been around for like about a year, but we've been taking it pretty slow and just wanted to be really confident in the product. And so not really pushing the marketing very much, just getting everything really stable. And we're just starting to like say hello a little bit more. Let people know we're here in places like this. So I really appreciate the time and just getting to share your audience that this is one of these little sliver of places that we're introducing it. It's like here, there's a review on Sound, and then there's going to be like one or two more. I think we'll get to the point where we sell out our production ability, and then we'll have to go with figure out that and go to the next step. So anyway, that's where we're at right now. Introducing ourselves, getting stable, getting our name out there, getting more users. All the info is at alderaudio.com. Probably not going to be any changes in the near future as far as like mics we're offering and things. It's going to be the H44, the H44S, and we're just going to be working on more demos, more content. I'm going to be trying to do a little training content on our YouTube channel, so talking about impedance and the mic and the voicings and just trying to get people to understand more. And that's kind of it. So go check out the website, alderaudio.com. And thanks a lot, Ryan, for having me on the channel.
Yeah, man.